envision megastructures that surpass planetary scales, Dyson swarms harvesting stellar energy, black hole farms extracting Hawking radiation, and generation ships ensuring the continuity of our species. These concepts are not just science fiction, they represent critical engineering endeavors that could shape humanity's future. As global initiatives accelerate, the future of civilization depends on our ability to transcend Earth's limitations. Join us in exploring the innovations that are poised to redefine our place in the cosmos. Dyson sphere. Imagine a civilization so advanced that it harnesses the total energy output of its star, approximately 10 to the power of 26 watts, enough to power quintillions of lives. Proposed by physicist Freeman Dyson in 1960, the Dyson sphere is not a solid shell but rather a swarm of orbiting solar collectors. Each panel, made from self-replicating graphene, could be constructed by AI-driven drones mining mercury for raw materials. But why undertake this ambitious project? The energy could fuel supercomputers capable of simulating entire universes or perhaps be used to signal our existence to extraterrestrial civilizations. Scientists today are scanning distant stars for unnatural infrared heat signatures, which could indicate the presence of alien Dyson projects. However, the construction of a Dyson sphere would require us to master nanotechnology and space-based manufacturing at scales currently beyond comprehension. Critics warn that a Dyson sphere could signify humanity's transition from a planet-bound species to cosmic titans, or it could attract hostile civilizations that fear our exponential growth. The stakes are high. Controlling a star's power could fundamentally redefine life as we know it. The O'Neill cylinder is a concept introduced by physicist Gerard O'Neill in 1976. He posed the question, why live on planets when we can engineer paradise in space? These rotating habitats simulate gravity through centrifugal force, using mirrors to direct sunlight for agriculture and to create seasonal variations. NASA's Artemis program is currently exploring lunar versions of this concept. However, building full-scale O'Neill cylinders would require mining trillions of tons of steel and silicon from asteroids. Companies like Blue Origin and Orbital Assembly are planning to develop prototypes by 2050, but there are significant risks involved. For instance, a single micrometeorite breach could lead to the decompression of the cylinder. Psychological studies also indicate that prolonged rotation might cause a condition known as space vertigo. Ethically, important questions arise about who should have priority access to these habitats. Should it be the wealthy, or refugees fleeing climate disasters? Although O'Neill envisioned these structures as egalitarian utopias, without global cooperation, they could devolve into feudal states controlled by corporate oligarchs. Despite these challenges, O'Neill cylinders offer the exciting possibility of preserving Earth's biodiversity in space, while also helping to heal our home planet. The space elevator, a concept born in 1895 when Konstantin Tsiolkovsky envisioned a celestial castle tethered to Earth. Today, engineers calculate a 62,000-mile carbon nanotube ribbon could slash launch costs to $100 per kilogram. Japan's Obayashi Corporation claims they'll build one by 2050, but challenges are Herculean cosmic rays degrading the tether, hurricanes, and space debris. A snapped cable could whip around Earth at hypersonic speeds, devastating cities, yet success would revolutionize humanity. Orbital factories could mine asteroids and lunar colonies would flourish. Philosopher Anders Sandberg warns, cheap space access might democratize the cosmos, or let monopolies privatize it. Imagine Amazon controlling the elevator's cargo, or nations weaponizing it. The elevator isn't just engineering, it's a geopolitical tinderbox. But if we succeed, it becomes humanity's bridge to the stars, a symbol of unity or division. Orbital rings. Imagine a world where reaching space costs less than a plane ticket. In 1982, physicist Paul Birch proposed the concept of an orbital ring, a superconducting structure located 500 miles above the Earth, spinning faster than the orbital velocity. Magnetic sleds could then accelerate payloads to 12 kilometers per second, allowing them to escape Earth's gravity without the need for rockets. Constructing such a ring would require approximately 10 million tons of material, likely sourced from near-Earth asteroids. The energy costs for this project would be around 5% of global GDP over the course of a decade. However, the potential rewards are astonishing. Zero-emission space travel, orbital solar farms, and sustainable supply chains to the moon. Yet, the risks are significant. A failure in the ring could lead to fragments raining down as molten debris, potentially triggering an extinction event. Politically, questions arise about governance. Would it require a United Nations treaty, or would a corporate alliance, perhaps involving companies like SpaceX and Google, take control? Historian Yuval Harari warns that orbital rings could usher in a post-national era, blurring borders and national identities. Alternatively, they might exacerbate inequality, allowing a spacefaring elite to leave Earth behind. The concept of the orbital ring transcends infrastructure. It serves as a reflection of humanity's aspirations and challenges. Dyson swarms. Before we conquer other stars, let's focus on mastering our own solar system. Dyson swarms consist of millions of AI-piloted mirrors designed to harness sunlight. These swarms could potentially terraform Mars or transmit energy back to Earth. The European Space Agency's Solaris initiative is currently testing prototypes, but scaling up these efforts will require factories on the Moon to produce drones using lunar regolith. However, there are risks involved. A misdirected beam of sunlight could accidentally scorch cities or ignite conflicts over resources. Ethicists are raising important questions. Should we prioritize addressing Earth's climate crisis over pursuing ambitious cosmic projects? Elon Musk argues that these swarms could serve as a backup for civilization if Earth faces catastrophic challenges. However, some indigenous groups are concerned about what they see as solar colonialism, warning against turning the sky into a corporate-controlled grid. The concept of the swarm encapsulates a critical dilemma. While technology has the potential to empower us, it can also lead to enslavement if not guided by wisdom. The question remains, will we use this technology to nurture life, or will we use it to dominate it? The Matryoshka brain is a concept of a supercomputer so vast that it uses the energy of a star to simulate realities indistinguishable from our own. Named after Russian nesting dolls, this megastructure's outer layers capture waste heat from the inner ones, achieving near-perfect efficiency. Physicist Seth Lloyd estimates it could perform 10 to the power of 42 operations per second, capable of simulating every human thought ever conceived in a nanosecond. But why would we build such a structure? Is it to solve the problem of entropy, to resurrect the dead in digital afterlives, or to escape a dying universe? Philosopher Nick Bostrom raises a critical question. If we create perfect simulations, how can we be sure we are not already living in one? This idea leads to various ethical dilemmas. Would uploaded minds retain free will, or would they become slaves to the machine's logic? Meanwhile, it's possible that alien Matryoshka brains already exist. The search for extraterrestrial intelligence, SETI, listens for unnatural energy patterns in pulsars. However, building a Matryoshka brain could lead to existential narcissism, where we trade the tangible cosmos for a form of silicon godhood. Ultimately, the question remains, will we choose to live in reality or to dream forever? Stellar engines are proposed solutions for humanity's survival in the face of galactic collisions or rogue black holes. One such concept, the Kaplan thruster, named after physicist Matthew Kaplan, aims to move our sun. This megastructure would utilize solar wind to propel the sun at a speed of 50 kilometers per second. So, how does it work? A magnetic field would direct plasma ejected from the sun into a jet, while hydrogen harvested from interstellar space would fuel fusion boosters. Over a span of 1 million years, we could cruise to safer regions of the cosmos. However, this ambitious endeavor requires energy equivalent to all of humanity's current output for the next 10,000 years. What are the risks? If miscalibrated, the project could strip away Earth's atmosphere or even plunge our planet into darkness. Astronomer Avi Loeb suggests that this may be a necessity. Civilizations that stay sedentary go extinct. On the other hand, critics argue that it could be seen as cosmic vandalism, disturbing the delicate balance of gravity. So would we become wanderers like ancient nomads, perpetually chasing new horizons? Or is the universe ours to reshape? Generation ships are interstellar arcs that demand more than just engineering. They test the very essence of humanity. These vessels must maintain closed ecosystems capable of recycling 99.999% of water and air, a challenge made possible only through synthetic biology. CRISPR-edited crops could be engineered to thrive in the unique conditions aboard these ships, while artificial intelligence manages the distribution of resources. However, the threat of social decay is significant. Studies of crews living in the isolation of Antarctica indicate that such environments can lead to paranoia and the formation of cults. Would a 200-year voyage to TRAPPIST-1 ultimately result in mutiny or transcendence? Ethicists have proposed the creation of mission religions to help maintain social cohesion among passengers, while transhumanists have suggested the idea of cryo-freezing the crew during transit. Yet the most profound risk lies in the existential dilemma. What if they arrive at a new world only to find it already inhabited? NASA's 2023 study considered generation ships to be feasible but fraught, a risky venture where failure could mean extinction. Do we dare to send our children's children into the void, or is the greater danger in remaining stagnant? To transform Mars, we would deploy fusion bombs to vaporize the polar ice caps, thereby releasing carbon dioxide to initiate global warming. Following that, we could introduce genetically engineered cyanobacteria, taken from extremophiles found in Antarctica, that would photosynthesize oxygen. SpaceX estimates it would take about 300 years to create a breathable atmosphere. However, ecologists express concerns since Martian soil contains perchlorets, which are toxic to Earth life. Should we instead consider engineering humans? Synthetic biology startups are already offering UV-resistant skin genes. The ethical implications are complex. Is terraforming an act of colonialism? The UN's Outer Space Treaty prohibits claiming celestial bodies. Nonetheless, Elon Musk argues that life must become multiplanetary to survive. Meanwhile, indigenous leaders caution against repeating the exploitation seen on Earth, stating, "Don't turn Mars into your next strip mine." This raises a profound question. If we have the ability to terraform, should we? Or does true advancement lie in exercising humility? In the universe's twilight, black holes represent the last source of energy. A 1-meter black hole, which weighs as much as Mount Everest, emits Hawking radiation equivalent to that produced by 10 nuclear reactors. To harness this energy, we would need a containment field 100 times stronger than Earth's magnetic field. Theorists at CERN propose creating micro-black holes through particle collisions, but critics are concerned. What if one falls into Earth? A paper published in 2024 suggested anchoring these micro-black holes in lunar orbit for safety. The benefits? Near infinite energy for millennia. The risks? A breach could unleash a planet-devouring vortex. For civilizations facing heat death, it's a Faustian bargain risk annihilation for the prospect of immortality. Stephen Hawking once remarked, "Black holes aren't so black, they're our final hope." But would you trust humanity to handle such cosmic fire? Skyhooks can be thought of as cosmic catapults, rotating tethers that propel spacecraft across the solar system without the use of fuel. For example, a 600-mile skyhook on Mars could fling probes to Saturn in just a few months. SpinLaunch's ground-based prototype currently accelerates payloads to speeds of 6,000 miles per hour, but orbital versions would require advanced materials like nuclear-processed Xylon. However, there are significant risks involved. If a tether were to snap, it could create dangerous shrapnel, endangering satellites and space stations. NASA's 2022 feasibility study warned that the potential for debris could lead to a situation similar to Kessler syndrome on steroids, where space debris could drastically increase over time. Despite these concerns, startups like Breakthrough Starship advocate for skyhooks as humanity's interstellar railway. Some military organizations are interested in using skyhooks for rapid troop deployment from Earth to the Moon, raising concerns about the potential militarization of space. Yet, skyhooks could also democratize space exploration. Imagine a scenario where anyone could explore the galaxy with ease, like having a backpacker's guide to space where individuals could hitch a ride to destinations like Europa. The question remains, will we weaponize this technology or share it for the benefit of all? Quantum communication rings offer a solution to the challenge of interstellar communication, where light-speed delays make real-time conversations impossible, unless we find a way to bypass the laws of physics. quantum-entangled particles could enable instant messaging across galaxies by deploying rings of satellites as relays. For instance, China's Mikius satellite has already achieved quantum encryption between Earth and space, but scaling this technology requires stabilizing qubits in deep space. The potential benefit? A galactic internet that could connect colonies in real time. However, physicist Michio Kaku warns that while entanglement cannot transmit data, it can be likened to a cosmic Morse code. To overcome this limitation, one possible approach is to combine entanglement with lasers to create encrypted carrier waves. There are also ethical dilemmas to consider. Who should control such a network? Could we adopt a decentralized Web3 model, or would it fall under the control of an authoritarian regime? Additionally, what if we were to receive a message that was not intended for us? These rings represent humanity's deep desire for connection, but in the vastness of the cosmos, not all voices may be friendly. The Alderson disk is an astonishing concept that redefines the boundaries of human imagination. Proposed by science fiction author Dan Alderson, this megastructure takes the form of a colossal disk with a star at its center, providing both gravity and light. The inner edge of the disk orbits perilously close to the star, while the outer rim enjoys a state of perpetual twilight. To prevent structural collapse, the materials used in its construction would need to be at least 100 times stronger than graphene, potentially made from quark matter forged in neutron stars. The habitable zones would occupy a narrow band where temperatures closely resemble those of Earth. But what would be the purpose of such a vast structure? One possibility is to accommodate quadrillions of inhabitants or to serve as a cosmic zoo, preserving every species that has ever existed. Astronomer Anders Sandberg estimates that the mass of the disk would exceed that of Jupiter, necessitating the dismantling of entire star systems to gather the required materials. However, there are significant risks involved. A single asteroid impact could destabilize the entire disk, jeopardizing the lives of all its inhabitants. Ethically, one might ponder if it is an act of hubris to create such a colossal structure, or if it constitutes a moral duty to maximize life in an otherwise barren universe. The Alderson disk ultimately poses a profound question. Are we the architects of our destiny, or merely ants rearranging the stars? The Birch planet is a fascinating concept that proposes building a planet around a black hole. This idea, theorized by physicist Paul Birch in 1991, envisions a megastructure designed as a shell encasing a black hole, utilizing its gravity for energy and light. The inner surface of this shell could host continents illuminated by X-rays that are converted into sunlight. Additionally, the rotation of the black hole could be harnessed to power cities through a process known as the Penrose process. To withstand the tidal forces from the black hole, this shell would need to orbit at 0.9 times the speed of light, which would require materials beyond what is currently known in physics. The benefits of such a structure could be astounding, offering near-infinite energy and the potential for significantly extended lifespans due to time dilation effects near the black hole. However, there are considerable risks. A miscalculation in the orbiting mechanics could cause the planet to fall into the event horizon, leading to its erasure from reality. Philosopher Nick Bostrom raises an important question. Would Birch planets lead to the emergence of enlightened post-humans, or would they give rise to immortal tyrants? Moreover, what happens if the black hole begins to evaporate? According to Hawking radiation theory, even massive entities are not immune to death. This presents a haunting paradox. In our quest to conquer death, we may be playing with the very essence of oblivion. Asteroid megastructures. Why build from scratch when asteroids offer trillions of tons of iron, nickel, and water? NASA's Psyche mission targets a metal-rich asteroid, but visionaries like Gerard O'Neill viewed them as cosmic building blocks. AI-driven nanobots could reshape asteroids into O'Neill cylinders or solar foundries. Companies like Astroforge plan to mine platinum for Earth, but megastructures require more than just mining. They envision asteroids as factories, farms, and shipyards for starships. However, there are risks involved. Spinning an asteroid too quickly can cause it to fracture, and excessive mining can destabilize its orbit. The 1967 Outer Space Treaty prohibits national claims to celestial bodies, but loopholes allow corporations to profit. Indigenous activists argue that celestial bodies aren't real estate. Still, without resources from asteroids, the concept of megastructures remains merely a fantasy. A crucial question arises: will space mining benefit all humanity, or will it enrich a privileged few? Von Neumann probes. Imagine machines that can clone themselves endlessly, consuming asteroids to create new explorers, a concept known as von Neumann probes, formulated by mathematician John von Neumann. These probes could potentially cover the galaxy over the course of millennia, but they require artificial intelligence that evolves beyond human control. Breakthrough Starshot's laser-propelled microchips hint at this concept, but true self-replication would need molecular three-dimensional printers and AI capable of learning to mine alien worlds. However, there are significant risks involved. A single coding error could trigger a gray goo apocalypse, where these probes could strip planets bare to fuel their endless replication. In 2022, UC Berkeley's Project AutoFac simulated probe ecosystems and found that if left unchecked, they could consume entire star systems within centuries. Ethicists are calling for Asimov safeguards, laws designed to prevent harm to living beings. But can we truly encode morality into machines? Meanwhile, SETI's 2024 report raises concerns. Broadcasting probe blueprints could alert hostile aliens to our existence. Despite these concerns, some proponents view these probes as humanity's chance at an immortal legacy. Even if Earth were to fall, our mechanical descendants could potentially survive long after the stars themselves fade away. Would you trust a robot to carry your DNA, or is this merely hubris masquerading as hope? The concept of ringworld, popularized by Larry Niven's novels, describes a megastructure that consists of a ribbon of habitable land encircling a star, held in place by centrifugal force. Unlike planets, this structure boasts a surface area equivalent to 3 million Earths, potentially hosting quadrillions of inhabitants. However, engineering such a structure requires materials that are 200 times stronger than graphene. Physicist Robert Zubrin suggests using active support through electromagnetic stabilizers, while MIT's Space Megastructures Lab, established in 2025, is exploring the creation of mini-rings using lunar regolith. There are significant risks involved. For instance, a meteor strike could rupture the ring, causing atmospheric loss to space. Additionally, shadow squares, orbiting panels, are designed to replicate day-night cycles, but if they fail, entire continents could either overheat or freeze. Cultural critic Donna Haraway has criticized ringworlds as a manifestation of the ultimate Anthropocene arrogance, whereas astrobiologists believe they could help preserve Earth's biodiversity in the event of a collapse. However, the most pressing challenge is ethical. Do we have the right to cage a star? Astronomer Jill Tarter warns, taming a sun is playing God with thermodynamics. Yet for a civilization eager for endless exploration, the idea of a ringworld entices us with the question, why settle for planets? The space fountain is a concept that utilizes pure momentum to defy gravity, relying on kinetic energy rather than traditional structural materials like steel. Proposed by physicist Robert L. Forward, it operates by using magnetically accelerated particles to push a structure skyward, enabling the support of orbital platforms without the need for rockets. In 2023, Japan's Skypiercer initiative tested a 1-kilometer prototype. However, scaling up this technology requires materials that can withstand atomic-scale erosion caused by tungsten particles traveling at speeds of 12 kilometers per second. The energy demand for such a system is significant, around 10 gigawatts, enough to power 10 million homes, to sustain the particle beam. There are notable risks associated with the space fountain. For instance, a power outage or an earthquake could lead to the collapse of the tower, resulting in molten debris raining down across vast areas. Elon Musk has dismissed fountains as sci-fi distractions, but they hold the potential to democratize access to space for nations that lack established launch sites. Ethically, there are questions about whether these fountains could disrupt SpaceX's monopoly on orbital launches or instead centralize power in nations harnessing fusion technology. Meanwhile, DARPA is investigating military applications, such as instant satellite deployment or even orbital weaponry. The space fountain embodies a paradox. To reach the stars, we must remain grounded on Earth, supported by a lifeline of energy. From Dyson spheres giving rise to gods to skyhooks launching us into the unknown, these megastructures compel us to reflect. Will we become stewards of the galaxy or repeat the scars of Earth among the stars? The answer depends not on machinery and technology, but on empathy. If we build to uplift all forms of life, the cosmos can become our sanctuary. If we fail to do so, it may become our tomb. So, dream boldly. But always remember the fragile blue planet that gave us the means to soar. Until next time, stay curious. The universe is counting on you.